And just to warn everybody, we are recording the session. For those who do not want to participate because it's being recorded, be aware that it is being recorded. Okay, over to you, Mitch.
Thanks so much, David. So good morning, good afternoon, everyone. My name is Mitch Simko. I'm not David Stokes. I recently joined Ribbon's IP Optical Solution Marketing team, and David kind of asked me to take this session for our North American audience. So I'm really excited to be here, and I think we've got some interesting things to cover in this market. I've been just a little background on myself. I've actually worked with the utility market for the last 7 years, so I've got lots of good experience, and really we're seeing lots of change coming in the utility market. Lots of things, we're going to get into some of those trends in terms of things about how the shift to green energy like wind and solar, and the need to modernize infrastructure, including communications. And the comms is really the heart of all this. It really underpins a lot of the things utilities are trying to do. And we wanted to show for our partners that the utility market, certainly here in North America, and I know David has a similar chart for EMEA, really is a significant market. You can see it here split by IP aggregation and DWDM. This is an estimate that we made based on some Signal AI results for spend in the enterprise market. But you can see, it basically varies between $350 to $400 million a year. One of the unique things in the North America market is the shift to broadband. We'll talk a little bit later how, there's probably north of $100 billion of federal funding going in to fund broadband in rural America. And utilities can play a really key role in that. There's a need for middle mile, and that I'm not even sure that money is really factored into these estimates. I would say it's almost upside on some of these. So a really exciting market to be in. I mean, this has been a key market, critical infrastructure for Ribbon, and we're really excited to take this now into the North American market. Now, what are the issues facing utilities? And this is a chart I've kind of used from our friends at Black & Veatch, one of the leading engineering consultants here in North America that does an annual survey at the CXO level and asks utility executives, like, what are their top 3 challenges that they're facing? And they do this annually. This reflects the most recent 2023 as well as compares to the previous year. And you can see here, we highlighted a couple items that we felt were really relevant for a communication network. So the first one, and this is no surprise, is the integration of renewables into the grid, right? So we'll talk a little bit later. Some of the key growth in the market is from renewables, whether solar or wind, battery for storage. And utilities really have a challenge with integrating these new renewables into their main grid. And we'll talk a little bit about that later. One of the challenges of it is that energy isn't as stable as that of traditional sources like coal, natural gas, hydro, nuclear. So there's a need to put lots of sensors on it to really track the quality of the power that's coming onto the grid. And utilities also need a way to things like teleprotection play a really key role, because if the quality of that power coming in the grid isn't to their specification, they really have the ability to shut it off so it doesn't destabilize the rest of their grid. So this is something, no surprise, this increased from 2023 from 22. And I think this will be top of mind for a while. The second is aging infrastructure, and this covers everything. This isn't just all about comms, this is about everything, power lines. Another big concern is can the power grid support all these new renewable, all this energy generation? And there's some techniques being done to look at that. So the grid itself needs to be modernized, but from our focus, it's really about the SONET network, right? The SONET network that was used for the comms in the past, it really can't keep up with the demands of a modern utility. And so utilities are really looking at modernizing that. And some have already gone through this journey, and others are still embarking on that journey. Moving down, and this is kind of related, is aging workforce, right? So the very people who grew up on Sonnet, who manage those equipment, well, they're reaching retirement age. They're retiring, and that's a big challenge. If you have a Sonnet network, it's not just about. It's a challenge to find spares, but also the very people who know how to manage that network are retiring, right? So the folks coming out of college now, they're not going to know Sonnet. They really only know Packet and optical. Distributed energy resources, I mean, that's kind of related to the first point. This is really about the fact that the grid is moving from this one-way generation, transmission, distribution to the kind of a bi-directional means of energy where you're going to have multiple sources of energy, again, coming from renewables, coming from traditional sources. Folks putting solar on their buildings and generating power, and they have excess they have to put on the grid. All of that, again, is how do you manage that, right? A big challenge for utilities. And the last one we highlighted, this, I'm even surprised this low down, is cybersecurity, right? We've seen this over the number of years. We know the bad guys would love nothing than to take down the U.S. grid. We've seen some other attacks, more physical attacks on some substations, utilities, place this very high. So I would think this would be even higher up the list here, but it's still a key point. So really everything utilities do cybersecurity has to be in consideration. So lots of things, lots of interesting challenges that are coming about. It'll be interesting to see. I'm sure that they're in the middle of their 2024 survey. I'll be curious to see how that pans out. So really the key three, and this is something that I know David put together, and I like this as kind of the 3Ds, really the foundation for smart utility. Really, I'll start with the left, decarbonization. Right, that's again really put the push towards green energy. The fact that that's where a lot of the growth is going to come from. As a result of that, the network has to become much more decentralized. There's a lot more devices to manage, whether it's, again, all those sensors on a solar farm, on a wind farm, in battery, on EV charging. We'll talk a little bit about that later. And as a result of that, the need to digitize, right? And this is not just, again, going from Sonnet, but the fact is that all these new devices are really packet-based. They're all Ethernet-based. So it really is a network has to consider the basic OT, legacy, keep the lights on, but has to consider all these new devices coming in. And so utilities recognize they have to modernize their network. Sonnet was never designed to really meet the needs of this modern utility. And we really have to help utilities, make that journey towards a modern utility network. So I like this chart again. It kind of illustrates the kind of that shift, right? So if you go on the left, utility 1.0, this is really kind of the traditional, keep the lights on. I need, I'm taking advantage of sensors that have traditionally been used to kind of track the performance of the grid. And so I need very high availability, even better. I know 5 nines is shown here, but almost better than 5 nines kind of reliability utilities really depend on to keep the lights on. They need very high resiliency. They need low latency for those services. And this, by the way, doesn't go away. This is always going to continue because this is always core to a utility business. But moving to the right, the utilities are really, again, shifted to this kind of utility 2.0. And this is very much packet-based, tends to be more IT-based. So a lot of the new services that utilities are doing, things we just talked about in the previous chart, tracking these new renewable sources, sensors, doing security cameras for cybersecurity, moving to the cloud, AI, I mean, all these new things. Well, that's all, it's all packet-based. It's much more scalable, requires much more bandwidth. Here in North America, again, the consideration, if utilities are building a middle mile for broadband, have to be ready for that. So really the requirements of the utility 2.0 are really quite different than utility 1.0. But the fact is you can't ignore utility 1.0. It's still required. It's still core to keeping the lights on. So it's quite a challenge that, a lot of times in IT, when we talk about these, I move to this new generation, I can kind of forget the previous one. Utilities can't do that. Utilities have to maintain those requirements because it's core to their business. Just to give you an illustration, and this is a chart, I looked at a similar chart a year back. I remember once a customer asking me, a customer who was looking at migrating from Sonnet to a packet optical asked, how much bandwidth does a utility really generate, right? Why do I need such a big network? I'm only familiar with my SCADA and stuff. And so we looked at a couple of examples of things that actually have big bandwidth hogs, right? Things that generate a lot of bandwidth. And so we looked at 3 of them, and we added a couple. But I'll focus on the three top ones. So the first is surveillance cameras, right? And so this is becoming even more important now as we see, we're not even talking about the bad guys in Russia and China. We're talking about even domestic issues where folks have been taking out substations, right? We saw that in North Carolina, where some people came in and shot up a couple of substations and knocked down power. There was one situation where power in like a small community was taken out for like a week, right? Imagine having to live without electricity for a week. So security is really key, and that's more physical security. And to do that, you need lots of surveillance cameras, right? And I think the more the better these days. And these surveillance cameras aren't something like in the past where you'd had some security guy like monitoring them. This can't be done manually. You have to backhaul that surveillance traffic back to a central data center. You likely are starting to use AI techniques to identify, are there any funny things going on? Is someone kind of casing it? Is somebody walking around a substation that shouldn't be there? That's the kind of stuff where security, has to be backhauled, and it's really going to be these advanced techniques in the cloud that are going to be used to be proactive on surveillance. The second is smart meters, right? So this is almost becoming table stakes. I don't know what the latest percentage. I know it's north of 60% of U.S. households have a smart meter. This used to be just for billing, but now utilities use this to track real time, near real time energy consumption. They want to know, especially now we're coming into the peak of summer here. I'm in Atlanta. I haven't seen a July this hot in years. And we haven't even hit the peak of the summer. So I think utilities, their networks are going to be stressed to the greatest. And so they really have to know, are there hot spots going on in the grid, and they need to shift energy around it to meet those demands, right? So smart meters are very key to this. So if you have a utility with just 1 million subscribers per day, and that's not really a lot, right? We know utilities are larger than that. A utility with 1 million subscribers will generate 1 terabyte of traffic a day. And again, all has to be backhauled to a main data center. And the third one we show here is synchrophasers. This is kind of a new device that was introduced in the last couple of decades that basically tracks the state of the grid 30 to 60 times a second, much more frequent than in the past. Used to be every 4 seconds. This is really key, again, to tracking and identifying outages before they turn into a big power outages. And then we added a couple of new ones, right? Because this is really related to renewables. So things like sensors and solar farm, wind turbine sensors, which are key. They need to be proactive in the maintenance of wind turbines, and EV chargers, right? All these EV chargers, a lot of them are failing, right? Because they're not well maintained. So those companies have to maintain. The utilities want to have a good sense of what's going on with those chargers. They have to be, maintained to the same level as the grid. If EV, if people are going to be confident in charging their EVs. So just those the first 3 I mentioned adds up to about 6 to 8 terabytes of data being generated per day, and all of that has to be backhauled to a data center and then backed up, typically to a backup data center, some of it going to the cloud. So if you just look at this, and I could probably go on and on with other devices, that the bottom line, a Sonnet network was never designed to handle this much traffic. So it's really a no-brainer now that the networks that we're seeing built typically are a minimum of 100 gig, because they have to be ready to handle this type of traffic. If we look at water and gas as other utilities, they have similar demands. They're going to have SCADA. They're going to have sensors, for example, on a gas pipeline. They need to know if there's a leak in a gas pipeline to shut it down, Same on a water network. They have similar surveillance requirements, so they're going to have surveillance cameras everywhere. And same thing, they're going to have smart meters to track water and gas usage. So you can see it's a very similar for really all kinds of utilities are faced with this, kind of demands. So this kind of brings us to the point of we've got this IT network and we've got OT network. And these are two worlds that traditionally were built with separate networks. They were silos, right? The OT guys, they built their networks. They're in task. And by the way, if you don't know what the word OT, it stands for operational technology. These are the guys that are mandated with keeping the lights on. That's really all they care about. So they are very much want mission critical kind of performance. They need to know if there's a power line issue, they need to pull that out of service within a power cycle. So very, very deterministic. Now the networks they built traditionally were SONET. They are, we continue to hear that those legacy SONET muxes are all going into life. I used to be, by the way, the product manager for the Nortel Optera Metro 3500. If you remember that in the day, we introduced that in the late 90s, right? So they are still out there today. It was great. I don't think we ever anticipated 25 years ago that still be, working. But it's end of life. You can't get spares. You have to go on eBay to get spares. And back to the aging workforce, the very people who know how to maintain it are retiring. Now, so really, if you look, and we're going to go into this in a little more detail, some of the protocols for, packet, including IP and Plus, were never designed to meet these deterministic requirements of SONET. Now, on the IT side, again, it's kind of back to that utility 2.0. These are the folks interested in energy, energy consumption. They're interested in, more of the day-to-day internal business side of running the utility. A lot of the growth is coming, on this side, right? And they, an IP network, some of the traditional IP protocols are probably fine for them, right? So these two worlds are kind of colliding. In the past, they had built two separate networks, and now utilities are saying, I can't afford to have a separate network, and I need a single network that can really meet the needs of both of these worlds. And that's a challenge, right? But we'll talk about how we can deliver that. The final thing, again, that's more North American focused, again, is the rise of broadband. Once you bring broadband into the equation, you're dealing with hundreds of megabits of traffic, right? If you're building a middle mile, and we're seeing some examples where some of those small electric co-ops are, getting together, building a statewide network to take their traffic from their local community back to the internet. Once you consider that traffic, then you are into the hundreds of gig, and that traffic tends to be more IT. It's not as mission critical, but it takes a lot of traffic as well. So let's kind of look at this a different way, and I think this is a chart David and I worked on together, is really to say we wanted to map that OT IT traffic against some of the requirements. So we look at bit rate, reliability, latency, and security. So interesting enough, the OT type traffic, the SCADA, teleprotection, those synchrophasers I mentioned, measuring distributed energy, all those kind of in beige, they tend to have low bit rate, right? They're not generating a lot of traffic. They tend to be in the kilobits of traffic, but they are very mission critical. They're very key, again, to keeping the lights on. So you see they're always in the high part of need the highest reliability, lowest latency, highest security, at all times. So that's a key thing. That OT not going to go away. The IT traffic, this is the newer stuff. This is smart meters. This could be video surveillance, could be things related to the field. These things, as you can see, much higher bit rates, for sure, stuff like video. But the criticality is a little bit less. So not to say this traffic isn't important, but it doesn't need the sub 10 millisecond kind of latency performance that you need for the OT traffic. So it kind of comes in the middle, but it tends to be much higher bit rates. So you can see it's quite a challenge to put a network that does it all, right? Because that's what, to converge OT IT traffic, you need a network that can meet all those requirements on that chart. And we'll talk about how we do that. So we're going to go in a little bit more in depth, but one of the things we support our partners as is a very comprehensive portfolio, really to meet the needs of utilities and critical infrastructure. And there's kind of three key elements to it. So starting from the lower left is really our dynamic and deterministic packet transport, which is in our Neptune family. And this is where, a couple of unique things here to perspective. One is the support for legacy interfaces. Many utilities are not going to go modernize their substations. Their substations have been out there for 50 years. They do the job. They have lots of equipment, every single interface you could possibly think of, and they're not going to go spend billions to go replace it all with modern packet interfaces. They just can't justify it. So they need a network that can support those legacy interfaces that map it into a modern, scalable, deterministic packet infrastructure. And that's where Neptune really shines, because it gives you really the choice of different MPLS protocols that can be purpose-built for each traffic type. And we're going to go in a little bit on this a little bit later into detail, but example, MPLS TP is really ideal for that mission critical OT traffic. And then you have other MPLS protocols that are fine for the less critical IT traffic, but it might require more bandwidth. Then we move to optical transport. Again, this is key when you are building networks that traverse entire states or in regions. You need a network that can scale, and this is really our Apollo family brings in a full suite of optical feature sets, and I'm going to go a little bit more detail on these a little bit later, that really allow utilities to have that scalability and extend the networks across states and regions. And finally, what really brings it all together is Muse. Muse is our multi-layer automated network control, health, and security. It's a multi-layer management system that can look at both your packet and optical layers. And that's very important because you really have to look at both. You can't manage a network one or the other. You really, to holistically have to understand what's going on at each layer to be able to truly understand what's going on with your network. And again, I'll talk about a little bit more on that in depth in a later chart. But just to show you, we have a really comprehensive portfolio for our partners that really can help you succeed in the marketplace. So let's drill down just a little bit deeper on MPLS TP, some of our packet protocols, and protocols for MPLS have really come a long way, right? If you look at the start of the internet, really classic MPLS is referred to as IP MPLS, and that was great for traditional, best effort, non-mission critical type traffic. That's what the traditional internet was designed for, and it's great for that. But as we get into mission critical networks that are really key to utilities, IP MPLS isn't going to cut it. It's not deterministic enough to do that. So some protocols have been introduced over the years to kind of address that. One that's become more common is called RSVP-TE, and the TE stands for traffic engineering. So it builds on IP MPLS, but it allows the utility to engineer parts of their network to address deterministic transport. And the challenge with it, though, is very complex, right? Especially when a network scales into a couple hundred routers, it just becomes unwieldy to try and manage this and scale. Every time you want to add another router, another node, you literally have to go and re-engineer your entire network from scratch. So it's very, very complex, and it doesn't scale. SRTE, that's referred to as segment routing, that's a little bit more recent. That does a little bit better job of managing this, but still not perfect. Really, the protocol that's come out that's really ideal for mission critical traffic is what's called MPLS TP, or transport protocol, transport profile. It was really architected for mission critical type traffic. It was really for people who are familiar with SONET, will be very pleased with MPLS-TP because it really is very similar. It allows you to create dedicated tunnels for your mission critical traffic. It has very strong OEM, similar to that of SONET. It allows you to have protection switching. So if a main tunnel fails, it can switch to a backup with less than 50 milliseconds. So very, very similar to SONET. So many utilities now are really looking at MPLS-TP as their go-to protocol for running their mission critical traffic. Now, not to say you can't use the other protocols as well, right? Because MPLS-TP may not be, really optimized for your IT traffic. And so you really can continue to use these other protocols. We give you that option, and I'll share that in the chart. It's called Elastic MPLS, where it really gives the customer the choice of which protocol to use depending on their traffic type. And this is, again, another chart just to illustrate this. This is really to say and this is really the more legacy OT type traffic, the stuff that needs very low latency mission critical performance. This is really take that traffic, run it over MPLS-TP, run it back to your data centers, and again, it looks very much like SONET, right? So that's really why customers are embracing it, because if you grew up on SONET and you know how to manage it, you're going to be very pleased with MPLS-TP because very, very similar kind of transport-like a feature set, and that's why we're starting to see utilities really embrace it. Now, just to show Ribbon's experience in doing this, and Ribbon really comes from a very strong experience in Europe. These are examples of 5 utilities, and some of these are very extensive utilities that are deploying MPLS-TP. They recognize the limitations of IP-MPLS and have really opted to deploy that for their OT traffic. And you can see here some pretty examples. Our folks in North America may not be familiar with these, but I noted some very large utilities in Germany and Netherlands and Switzerland, and some that span across Europe. So it's actually it really shows that there's some success and experience in doing that. And in my previous experience, even here in North America, in some of the newer recent RFPs, we're starting to see utilities that's really, again, the go forward in terms of they're requesting MPLS-TP as a go forward protocol for, building up these kinds of networks. So I think, we're going to see more North American examples of customers, using that here as well. There's some similar things here. I mean, I think I'm going to make a couple of points on this chart. One is the term, middle mile, which is starting to take some traction here in North America. We've seen that used for broadband networks. We're starting to see that used in middle mile networks. Really, the definition of middle mile is it doesn't touch an end customer or an end, so an example, a network that wouldn't go right to the end, consumer or enterprise. Really, it's the aggregate traffic from, example, your substations, right? Back to a control center. So this is really, really where Ribbon shines. It's really having a family of products to meet that middle mile. And the other thing we mentioned, again, I think that's really key, is it really this multi-stack MPLS. It's really showing customers have a choice. If they want to have a very deterministic SONET-like performance, they can use MPLS-TP. If they want to have a protocol that may be better suited for best effort IT traffic, there's a whole range of choices here. It could be Carrier Ethernet, can be IP-MPLS, segment routing, as I mentioned. FlexC is another option. So lots and lots of choices. Customers really can pick and choose, really what best fits their needs. And that's really our role here at Ribbon, is to explain to customers what is that best choice to best meet your network requirements. And a good way to do this, I think, is, and this is kind of terminology we've seen in the industry the last couple of years, is really the concept of slicing, is creating network slices to meet these different, really, network SLAs, right? So the idea here is to create an OT slice. An OT slice would be, again, meeting the needs of that OT traffic, that mission critical traffic. An example there is you could use MPLS TP for that OT traffic, connect your substations together and meet that need. Now, for your IT traffic, which probably will require more bandwidth, but less, may not need as a low latency as OT, then you could create an IT slice to do that. And these slices can be determined in multiple ways, right? You know, we use the term slice kind of independently, but a slice could be a VLAN, a slice could be Flexi, a slice could be, you know, many different things. So don't think of it as any particular technology. It can be really just think of it as a segmentation of your network that has a different different network properties than another, right? And again, as we talked earlier about this convergence of OT and IT, this is really key. So traditionally, utilities built separate networks, maybe even on separate fiber for each of these networks. And really, the goal is to converge. So by having this concept of slicing, you can build a single network but deliver the appropriate SLA network, you know, characteristics that you need for each traffic type. So it's really a way to keep the OT and IT guys happy, but it's on a single network, right? And that keeps the management happy, you know. So I think that's key. So you know, basically, I don't plan to go into this chart in depth. This is really kind of, again, to show our partners that we have a comprehensive portfolio to meet the needs of this market, right? And so I'm going to start with kind of the IP routing, which is the Neptune family. I'll kind of start a little bit in the middle, which is the AR1000 series. These are really products more destined for the edge of the network. And you can see here, there's a whole family of products depending on what the need of the utility is, right? Everything from the low end 1012, it's kind of a DIN mounted hardened device that can sit on a pole, you know, that some utilities need. And there's a whole family of products, again, that can scale up. The higher ones tend to be more redundant and modular, meaning you've got multiple switch fabrics, you can plug and play different interfaces. The lower end ones tend to, you know, be more pizza boxes, which you know, don't have built-in redundancy, but you can achieve redundancy by stacking multiple boxes if that's what you want to do, right? So a nice family of that. Now there's also to handle the TDM traffic is an extension shelf where, you know, which I think is a really key advantage. So to handle all the low speed interfaces, you can buy, and it's a 3RU extension shelf, and in there's a whole bunch of there's a basically a daughter card, you know, mother card and daughter cards that you can mix and match those interfaces based on your need. And you can attach that to any one of these members of the Neptune family and have it managed as a single NE. So that's a real key, that you really can optimize your TDM traffic and your packet traffic for each site. So it's really, I think, unique in the industry, where some vendors really kind of tie you know, you kind of have to marry the TDM with the size of the box, resulting you may have to stack multiple boxes together. This really lets you optimize the right amount of TDM and the right amount of MPLS capacity for each site. As you get to the higher sites, and this is more for the, you know, closer to the, you know, closer facing the core of the network, that's where we get into the higher end XDR 2000 series. These are more high performance routers. This is, you know, products that can scale into multiple terabits, right? And this would be more for the higher end aggregation and core of the utility network. So really a nice family that really takes you from the access edge right into the core. Now the software, and I think this key, is really the same across the whole family, right? It's the same set of router software, same merchant silicon, you know, same building blocks. And that's key. So from a management perspective, anyone who's trained on any one of these can really use any member of the family. And that's really important as you move up. You know, you may want to add different products as you grow your network. And so from a training perspective, once you've really learned how the Neptune software works, it can be extended throughout. There's a new technique called coherent routing. It's kind of the ability to put pluggable kind of DWDM type optics, some gray, some colored, directly in routers This is kind of a new trend. I'd say it's less important for the utility market. Maybe it can be used, say, in a metro area. These optics can run up to 100 kilometers. Typically, they're standards based. So that's a trend we're starting to see. I'd say less maybe in the data center part of the utility market becomes important. This is really becoming a bigger thing in the hyperscalers, the Facebooks, the Googles. They're really starting to embrace this to interconnect their data centers. We talked about multi-stack MPLS, and again, really the key here is, again, elastic MPLS, the choice of those multiple MPLS protocols. It really lets the customer optimize the right protocol for the right traffic type, whether it's OT or IT. Network segregation, again, that concept of slicing, creating those slices. And again, the slices can be done in multiple ways. And again, each slice could use a different protocol depending on the traffic type. And finally, interop. Interop's really important because we know utilities aren't single vendor. They unless you're building a greenfield network, you're likely going to have existing vendors out there. So they want to know that the vendors they're working with can interop with their existing vendors. And so Ribbon has done a lot of work, and you can just see again some examples here. Certainly part of the standards forum in Europe of all the different testing that's done. And this is an example of a test bed where Ribbon was interop with a multitude of vendors out there. So customers have confidence that their Ribbon investment can interwork with other vendors that they may have in their networks today. The second key thing, again, I won't go into all this detail, is really on the optical side. So the optical underlay, really key for utilities, again, as you're expanding your network, you're wanting to connect your big data centers together, you want to connect your large control centers. DWDM becomes really important to this. And so really the key things here are scalability, the ability to scale in the future. Utilities may not need this much capacity, but Ribbon Apollo portfolio can scale up to 1.2 terabits per wavelength, right? Utilities may not need that day one, but it's nice to know that their vendor can scale to that in the future, right? So you're putting, even though you're putting in a network for today, you know that network has to be ready for the future. So that's really you can see here. There's a lot of things that are being introduced that customers can feel confident that they do have a pretty comprehensive optical portfolio that can underpin, is really the underlay for the packet networks I mentioned to you. And this again is to aggregate, this is really about aggregating the large traffic that comes off your Neptune packet networks. As I'm coming to the end, another last thing I think that's really key is migration, right? So customers who are on this journey from TDM to packet want to have the confidence that their vendor knows how to migrate them with the lowest risk, from TDM to packet. That's really key, right? Because many utilities and service providers have gone through this journey, but others haven't. And so the beauty here is to show that Ribbon has this experience. I've seen, and again, this is almost a topic for a separate webinar, is really to show the steps that Ribbon would take to help customers migrate that. And really, in a nutshell, it consists of building an underlay packet network, packet optical network, that's kind of your future. You keep your legacy SONET. When you're confident that your packet network is working to your satisfaction, you now start to slowly migrate your TDM to the new Neptune-based or Apollo-based packet network. Once you're confident with that, you slowly continue to move more TDM till eventually you moved everything. And then you can just take your SONET network out of service. Now, that may take multiple steps to happen, right? Because that obviously utilities want to have the confidence that this is going to work for them. And Ribbon has the experience of doing this with many utilities. And we have the step-to-step procedures to do this. And we have the staff, we have the services to support our utilities to make this transition. So we know this is really key because it's really, a lot of utilities, they're leery, right? Their networks are so key to the running of the power grid. So they really want to have confidence that when they make that transition, that it's going to go really well. And so Ribbon has the experience, has the services, has the techniques to help, working with our partners to help utilities make that transition. All right, so last thing, again, I'm going to touch on this, but I think this is, again, another topic for another webinar is really about Muse, right? So Muse is it's the secret sauce that underpins everything, right? It sits on top both Neptune and Apollo. It really allows utilities to have a multi-layer view of their network and really automate a lot of the things that are needed in this modern kind of utility 2.0 kind of network, right? These networks are much more complex than before. They're always going to be changing. There's going to be new devices being added. And so there's a need for a system to automate that, make it easy to track the status of the network. These networks come with advanced analytics, right? These networks are very smart. They collect a lot of data on the performance of the network, and no utility has the expertise to really manually look at that. So the beauty of these networks is the ability to take all that data and uncover insights, right? Be able to track things and basically tell you maybe something hasn't failed yet, but there's a trend here. There's something going on. Maybe it's a fiber band. Maybe something wasn't installed correctly day one. And it hasn't failed yet, but if a trend continues, it could fail in 6 months, right? And you want to be proactive about this. You don't want to be reactive. You don't want to wait till it's an outage at 3 in the morning and you have to send your crews out trying to figure out where the outage is. You want to be able to do this in business hours, being able to proactively look at what's going on in your network and deal with it when it's much more cost effective. The system has to be multi-vendor. Again, it has to interwork with your existing OSSs and your other vendors. And that's something, it has the interfaces, it has the northbound interfaces that are key to doing that. And this is built with a cloud native architecture. And again, that term, it's kind of ubiquitous these days. It doesn't necessarily mean that it's in the cloud, but it has to be cloud native, meaning it could sit in your data center or the utility data center, but it has to be ready to be set up in that cloud, support microservices and so on. And that's a really important thing, which this has been built on. So lots more we can talk about. I think this is almost worthy of a demo to really show the power of it. You have to really see it to appreciate it. All right, so my last chart, really hope we conveyed, really some of the powerful things that we've got here to support our partners to win in the utility market. This, again, we're building on strength and Ribbon and certainly in the European market. We're proven. We're bringing that to North America. We've already got a very extensive support staff and facilities here to support our customers. We have a big facility in Fort Lauderdale where we actually stage. So I really was impressed with this, where before a network is even shipped to customer, they will build the network out to the customer spec, allow a customer to come in and see the network the way it will be set up in their network, and it's only shipped to site once the network is to the customer satisfaction. So I think that's really, really powerful that they have that staging capability, so customers, really feel confident they really get it before it even goes into their site. We talked about how critical infrastructure is a key focus, and this was always a key focus for Ribbon from day one. So where many other vendors have to deal with, they're out there trying to sell to the tier 1 service providers. Sometimes the critical infrastructure isn't the key focus for them. And really to say for this segment, this is really has been and will continue to be a key focus for Ribbon. And we're just now really taking the message out here in North America. It's been architected for mission critical, and we get the requirements in the utility market, and we have experience doing that with some very large networks. Certainly we've seen in Europe, and even in North America, there's been some good success stories. You'll probably be hearing more examples in the future. We talked about Muse again. I really kind of touched on it. I think again that's worth coming back with a more detailed deep dive and demo, so you really can see the Muse is really the eyes and ears of your network. It's how customers will interact with their network, and it's really impressive. Customers have really been impressed with Muse, and so I think this is a powerful tool. This is a secret sauce, really, for our partners to go out there and really show the value of Ribbon. And finally, I've been really impressed in my short time in Ribbon, really to show that Ribbon, it comes from a large vendor, it's got large vendor capabilities, but it acts like a startup, especially when we talk about critical infrastructure. Because critical infrastructure is such a key vertical, it has the ability really to act like a startup for this market. So I think that's really impressive going after this market. When customers, really, when you're talking to customers who really understand their needs and really can react to them much better than some other vendors that have to chase, every single market segment. So that's really all I plan to cover. And I know I see 15 minutes left, and I see there's been quite a few questions in the chatter. So I'm going to look at that and see, and I assume David might be answering them. But let me see if I can bring back some of the questions. So let me go through this. And so first question was my point about how much traffic is generated by smart meters, and I gave the example for utility with 1 million subs. What about a smaller rural co-op with 10,000 subs? So absolutely, it's not gonna be as great as 1 terabit. I think we're just trying to make a point, though, that even for a rural co-op, it's still a significant amount of traffic. It's not gonna be a terabyte. It's gonna be in the gigabytes, but it's still showing an example for the co-ops that you need a scalable network. Sodom isn't going to cut it for that. Now for co-ops, I think the really important thing, the bandwidth hogger for that is going to be broadband, right? A lot of the rural co-ops are getting into broadband, and I've done studies again in my previous life showing that even for a co-op with, let's say, 10,000, the average co-op, by the way, is about 20,000 households. You're talking multiple hundred gigs of traffic that you have to get to the internet to handle that, even that smaller co-op. So I would say, so yeah, for smart meter traffic, not going to use, may need a huge network, but for broadband, absolutely. You're going to be ready for that. You have to have a very scalable network and in multiple hundred gigs to support that. Let me see the next question. So the question is about traffic encryption. Other industries need FIPS 143 compliance or whatever. So FIPS 143 is and I'm familiar with that from the previous life. That's more of a selling to the military, right? You want to sell to the DoD, you're going to need that. Utilities, I don't think they've made that as a absolute requirement. I think that's a nice to have for the utility market. Certainly if you want to sell for the Fed government, you're going to need that. But we do have a wide range of encryption options. I've seen solutions for MACsec for optical encryption, and so maybe we have to provide so that's something that we can get back to you with some more details of what's out there. But I think that's something my colleagues David and Jonathan will we will find out, but I've definitely seen those feature sets, and so we'll come back with those solutions, and they will meet the needs of the utility market. So absolutely. Make your presentation available afterwards. Absolutely, we'll do that. And I'm just looking here, CARP service encryption. Yeah. So I think David, you were suggesting that we have a follow up, and absolutely we need to come back with what's our security story. And from what I've seen, it looks very comprehensive, both at layer 2 and layer 1. All right, I mean that's the questions in the chat. Any other questions? Anyone else wanted to have a question about anything I covered? Oh, okay. Well, if yeah, maybe David, and I know you've been listening as well. Maybe David, you want to make some closing comments and see if any more questions come in. I don't know if you're on mute. Okay.
My headset had died. Sorry about that. Yeah, thank you ever so much, Mitch. Yeah, I think we should have a follow-up on the security area if anyone is interested. It's a very detailed area, but we do supply our IP optical equipment to many defense forces across the globe, and their security requirements make the utilities ones look easy, should I just say.
Yeah.
So yeah, and we have some very specialist professional services stuff to take it to another level. So absolutely, we can have that discussion with you, and we'll bring on our defence team if for any engagements that require that sort of level. And yeah, I think we have a great opportunity with this equipment. We're probably a market leader in Western Europe for utilities. We've only just really started looking and concentrating on North America, just because of lack of the right partners, a lot of people like you. And I think we've got a great opportunity to help you make a lot of business with a great portfolio. Yeah. So I absolutely think we've got a great chance.
Yeah, and like I said, I think there's some great follow-up topics here. I could see, I know our partner team wanted to follow up, but I could see coming back that we could talk about security if that's a big one. Certainly Muse, I could see. So we certainly look to our partners to come up with, what are the topics. Today, I kind of think we covered a lot of topics kind of, at a high level. And we can drill down, in any of these topics and really give us, give our partners a deeper understanding of some of those areas. I think there's lots of great stuff here, and I'm looking forward to supporting our partners to go out and win some utility business. And like I said, I'm here. I'm based in Atlanta, and I'm really happy to work with you to see some opportunities. Let's see here. Yeah, absolutely. Yeah, let's sit down and someone made the comment, looking forward to further understanding, and absolutely, let's do that. And I think that's what our partner team can facilitate those conversations. All right, I think good to know. I think those are all the questions. I mean, I think we've got a couple. Basically we maybe 7 minutes left, but I think if there's no other questions or comments, hope you enjoyed our session today. And like I said, I think this will be first of many sessions that we can delve into some of these topics in more detail. So, and like I said, feel free to follow up after the webinar. If you wanted to follow up with something after the webinar, feel free, reach out to our partner team, who can reach out to me or David. All right, so if that's it, I will shut off the recording, and we will look forward to seeing you next time.